cool. So that's it for functions. The problem we have right now is that the last one is the hardest, and it's sum types. So let me throw it to you. Do you want to hear a short, do you want to go through this like very fast now and then continue it next time, or do you want to like focus on maybe if you have some questions, or maybe just figuring out exercises and let's keep sums for next week? What do you think?
I mean, I would like to do like a short, you know, like a short explanation of sums, because I rewatch the stream like
Okay.
2 times, and I try to, you know,
Okay.
I try to make the most of the fact that you're helping me.
Okay, cool. So let's do this. Again, don't worry, like it's not a limited number of sessions, so we'll. But yeah, let's do a quick example here. Okay, so are you familiar with the enums in C#, like this thing?
Yeah.
So sums have sort of the same concept, except they're way stronger than enums. So let's look at a very simple example, right? So I was mentioning earlier this thing where you can do weekdays, and you can say something like Monday. Right?
Yeah.
So this is how you type it out.
Mm-hmm.
So what does this mean? So let's copy our thing here, our same format, just so we're consistent, right?
Mm-hmm.
So again, we're not mentioning data because we already know what data does. So weekday is a new type we just created, right?
Yeah.
So then Monday, Tuesday, all up to Sunday, let me put the parentheses correctly, are all new constructor, right? But then all of them are something like this. So it's Monday of
weekday,
Tuesday, etc. Right? Sunday as a weekday. Okay, does that make sense?
Yeah. So
cool.
far.
So basically, instead of like the constructors we had earlier here took arguments, right? They were like, okay, if you give me 2 integers, or if you give me a boolean, then I will construct the type that you created, right?
Yeah.
Well, these are already values. They don't need anything, right? They already are. Period. Right? It's already there.
Mm-hmm.
Okay. Cool. So then, what can we do with these sort of things? Well, we could definitely create values, right? We could do Monday of type weekday. You can say Monday is Monday, right? Like so. But this doesn't make sense, right? Because we could just use this thing, right?
Yeah.
So this is kind of like, sure, we can do this, but that's not very interesting, right?
Yeah.
Okay, so one other thing we could do is we could do something like to int, for example. Int. So we could say that Monday is 1 and then Tuesday is 2 and so on, right?
Mm-hmm. Okay.
So how do we do this? Well, we do to int, and then there are two ways to do it. One.
Okay.
Yeah, go ahead.
I think first you use this like the
okay, actually you might be able to do the simple way. So let's see.
To int mon.
Mm-hmm.
And wait. Okay, I was so proud of the fact that one of it. Okay, I didn't even think of what's coming next.
That's correct so far.
I used the constructor.
Mm-hmm.
So 1 equals 1.
Yep, that's it. And then we do all the others, right?
Yeah.
We don't need to do that, but let's just do like Tuesdays 2.
No.
And then do etc. Sundays, whatever 7, whatever it ends up being, right? Mm-hmm. Okay, so that's one option, right? So option 1, right?
Yeah.
Oh, interestingly, so let me show you something in PureScript, which is very interesting, and that's something that many other languages don't have. If you type this,
yes.
Well, actually, we didn't copy the type, so of course it complains. Let's also copy the type. So let's see what kind of error we're getting. So let's look at this thing here. Let's try to open it. Okay. So it says a case expression could not be determined to cover all inputs. The following additional cases are required to cover all inputs: Wednesday, Thursday, Friday, and Saturday. So basically PureScript telling us we forgot to handle our cases, and this could, like, what happens if we call this function Wednesday? Well, it will crash at runtime. So then PureScript telling us, nope, this is an error. You need to tell me what to do in all cases, otherwise I will not let you compile this program.
Yeah. So it allows us to automate the values?
Well, it's not automate, right? It just tells us that we forgot to handle all the cases and that it's an error not to handle all the cases.
Okay. I thought if I hover over it and like scroll a bit or something.
It will do it. I don't think it can do that, although it should be able to. So that's maybe an interesting. Although there might be some cases where it's hard to do, because this is a very simple example, but others could be harder. So I guess we if we want to add it here, then we need to add all cases, right? So Wednesday, Thursday, and Friday, I guess, and one more.
Yeah,
Friday and Saturday. And it doesn't care that you're not using the correct numbers, right? Right. As far as it cares, you could always do all of them equal to 1 or something, right? And then there's one more like syntactical way you could do it, but it's literally the same thing, but it's syntactically slightly different. You could like give it a weekday, like a name here, and you could say, well, let's do it to int prime, right? A different name. So let's call it to int prime because it's a different thing, and then we could say case weekday off. Okay, and then you can do Monday goes to 1, Tuesday goes to 2.
Okay.
Wednesday 3. Well, exactly.
Okay, so this is the same. Yeah.
Wednesday goes to 3, Friday goes to 4. I'm missing something, aren't I? Thursday.
Yeah, it's Thursday. Yeah.
Saturday goes to 6, and then Sunday goes to 7. Right, and it's literally the same thing. It literally gets compiled to the same thing. But it's sometimes it's easy. Like, this is useful to know, because sometimes you might want to do cases on multiple things at the same time, and I'll show you the syntax for that as well. But it's correct either way, right?
Yeah.
Okay, cool. So this is a cool way. So you were asking earlier, okay, what if I want to do bikes? Well, if the the type of bikes is known at compile time, right? So you know that there's like 5 types of bikes you care about, then you could do data bike equals to BMX, and then whatever else you want here, right?
Yeah.
So you could use a sum type for that, right?
Yeah.
Okay, cool. So these are sum types. Now, the tricky thing about, or the novel thing about sum types that you're probably not familiar with, is that they don't have to be like enums, because here is exactly like an enumerated value, right? It's kind of this you can do in C# as well, right? This sort of type. Okay, well, let's say that let's think what's a good example here. So let's say I want to what's a good example for enums that have a value? Okay, I have an example. So let's say we want to do a different sort of point. Okay, that's a point 2D with 2 integers, or a point 3D with 3 integers.
Okay.
And let's call it point T, right?
Okay.
So what does this mean? Let me structure the code so that it's easier to read. So, like, a point can be either like this or like this, and either of them are correct points.
Yeah.
Does that make sense?
Yeah.
And this is something you can't do in C#, right? You cannot add values to an enum like thing here, right? This is just a like this usually gets translated to an integer, right? So like weekdays, it's actually an integer, and these are like constants like 0, 1, 2, or whatever, right? In C# or whatever. But this is a bit trickier to do in other languages. So let's use our same like reasoning that we use for the others, right? So point t is a new type, right? And then point to d is a int to point t, right?
Yeah.
And then but also point 3d is an int to point t, right? So you can create a oh no, I hate this. Okay, does this work? Okay, it works now. Okay, so basically now there are two ways to construct values of this type, right? So like one of them would be point 2d of 1 and 2, but also point 3d of 1, 2, 3, right? These are all point t values. Yeah. Okay, so and this is like, it might not seem like a huge deal, but this is an insanely big deal in functional programming. And like once you get used to having these sort of types in like in functional programming, you'll start not remembering how you used to work without them, right? Like how do languages that don't have this work? And this is very useful for a lot of things, and I'll show you probably better examples. For some reason, I'm drawing a blank of good examples that are general right now to give you. But I mean, this is maybe a fairly reasonable one, although I'm not sure what kind of operations you could have over this sort of thing, because it's not like you could add a 3D point with a 2D point. Unless you assume that if it's a 2D point, it's on the 0 z, right? Maybe that's a reasonable assumption to make. Right, so like this is basically the idea for some types, right? So and then okay, let's think about okay, so let's think about let's give a simpler example, right? Actually, I'll keep this example here, but let's do an example with a 2 weekdays, I guess. So let's say data. So what's something that could have 2 different weekdays? Some event that happens twice a week, right?
Yeah.
Well, no, it's one or the other, right? So it's not twice a week, it's one or the other. So when can you have one or the other? So why would you need to have a bit on it?
Okay. So we're looking for an example where it's either
alternating week, where we have first, alternating week, I guess. So we have the first, which is a week day, and then second, which is a weekday. Right, so for example, the first week will be like on Mondays, and then the second week will be on Tuesday, some event, right? And then it's back on Monday, and then back on Thursday or something, right? Okay, cool. We figured it out. Okay, so we have this, right? So again, if we take this thing again, hopefully that's pretty clear right now. We have a alternating week, which is a new type. We have first, which is weekday to alternating week, right? And then I'll do this first, comma second. Does this look reasonable to you? Like they both have the same thing.
Okay.
Okay. And are both constructors. Okay. And then values are kind of like what? First of Monday, right? Or second of Tuesday.
Yeah.
Right? Okay, cool. So now let's think about it for a second. If we want to write a function, so again, if we want to do a value like f is going to be alternating week, so f will be like first Monday, right? We already said that. That's one example of a value.
You misspelled first.
Yeah. Okay, so then we have, what else do we have? Okay, so how do we pattern match over this, right? So let's say we want to return, let's say we want to return a string representation, right?
Okay.
Well, no, let's just say we want to know if it's first or second. So is first or second, or just is first. Okay, let's use this first. Right, so we want to know if this is a first or a second, right?
Yeah.
So what do we do it? Well, we do a pattern match, right? So we do if it's first of anything, then it's true, right?
Yeah.
So if there's anything else, it's false. Does it make sense?
Yeah. Yeah.
So this is how we can write it. One example, right? We could also say second underscore here, and that would be the same thing, right? But we don't really care, right? We know that if it's not first, it's always false.
Yeah.
Okay, cool. Then we could also get the weekday out of it, but let's not worry about that right now. Okay. So then the last thing I want to talk about is cardinality, and then we'll look at a lot more examples next time, right?
Mm-hmm.
So cardinality for some types. Okay. So let's look at first for a second, right? So how many values can alternating week have?
It's first and second. Oh, wait. Okay. So first can have 7.
Yes.
Second can have 7 as well.
Yep. So how many is it in total?
So, is it 4? Wait, no, it's not 4 because it can. I keep going to 49, but.
Well, it's not product, right? So let's start writing them down. So it's first Monday, right? That's a value.
Yeah.
First Tuesday, that's another value, right?
Yeah.
And up to first Sunday, right? So that's 7 values, right?
Yeah.
Okay, so then we have second Monday, second Tuesday, through second Sunday. That's also 7.
Yeah.
So how many is it?
That's why I said 49. Is it like 7 at the power of 2?
Well, it's not, because it's either one or the other, so it's just adding them, so it's just 14.
Right?
Yeah. Right.
Yeah.
So and that's actually why they're called sum types, right? So sum types. So the cardinality.
Yeah.
They're components, right?
Yeah.
We have weekday plus weekday, right? And we know that that's 7 plus 7, that's 14, right?
Yeah.
Okay, cool. And then, okay, what I forgot to do here, so type notation. Let's do this very, very quickly. So if I type A types A, or A types B, that means it's a product type. So something like data, some name, right? Product equals some make product, AB, something like that, right?
Yeah.
So that's a product. If I type A goes to B, then it's a function type. So something like, well, it's already A to B, right? So, sorry. I mistyped here. So if I type B to A, then it's something, B to A, right? It's something like A to B, right? And then if I type something like A plus B, then it's a sum type. So something like data sum equals to constructor 1A and then constructor 2B, right? Does that make sense?
Yeah.
Okay, cool. And then again, the way we type the functions in type notation is also the same way that we calculate cardinality, right? It's no surprise here, right? So we use multiplication for products with exponentials for functions and plus for sum types. Okay, cool. So then next time we'll talk a bit more about this sort of thing, because this is called the type algebra. And we can do some cool algebra with it. And I think I want to do that next time. So we do a bit more types. I want to do types and I want to do more functions and things like that, right? We get used to what we talked today and look at a few more examples. And then after that, the day after that, so let's create some sort of plan here. So we had like one was lambda, calculus, and then two, well, why am I doing this sort of thing? Okay, so two was is today, which was types, right? Then three, we want to do type algebra. Okay, type algebra, and then four, we want to do recursive types and functions. We'll just do them together because it like they're very connected to each other. And then we'll see. I guess then we do type classes and like the simple ones, like maybe we do type classes with records. We'll see if we can do both, and then we'll do semi-group and monoid. Although maybe we probably can do more than that. Yeah, we'll see. So the further ahead we'll see as we get there, and then we'll get into cool stuff like functors. Okay, so let's see. Let's do this sort of thing, right? Okay, so we are here right now. Okay, we have a plan for next time. So it's already 1:05. Do you want to spend another 5 minutes to figure out what to do for next time, or do you want me to send it to you later?
No, sure, yeah.
Okay, if you're tired, you can always tell me, like, I'm tired, I want to go sleep, and we can...
I'm like, okay, so something I need to explain.
Okay.
Did you hear me, like, yawn? It's
no.
not...
Okay.
No.
I actually didn't even hear you, but no worries.
Okay, it's because, so I have some... I don't even know how to say it properly. It's like gastric reflux.
Oh, okay.
It kind of affects my breathing now.
Okay, I'm sorry to hear.
No, it just happened.
Okay.
So I'm yawning because it's the only way that I can actually breathe properly, you know? So okay. I'm sorry if you could hear me today.
Oh, no, don't worry about it. I actually did not hear. So that's not what I was asking, but it's like we said that we'd do 2 hours and it's already 7 minutes past, so I'm just making sure I'm not... okay, cool. So let's just spend a few minutes to do like some sort of exercise, right? Mm-hmm. So we'll not solve them now. I just want to make sure you understand them before and that they're already written down.
Yeah.
So let's go through what sort of thing we already discussed, right? So I guess I won't. Like I told you how to do wrappers, but they're boring, right? So let's just do let's do an exercise with products, one with functions, or something like that. Let's figure out some interesting exercises. So let's see. For products, maybe. Okay, so maybe just what kind of things could be interesting here? Okay, let's say define. Okay, so define a type to hold information. About a user, which is a username, a string. Let's say an email, also string. Let's say age as int. And age, right? That's enough.
Okay.
So you need to define the type. That's obviously a product type. Okay, cool. So that's number one. Then number two, let's say write functions to extract each property.
Mm-hmm.
So for example, get user, that goes from user to string, right?
Yeah.
Does that make sense? Do you want me to write them all down, or can you figure it out yourself for the email and age?
No, yeah, it's fine. Okay, so did you say that you barely heard me today?
No, I said I barely heard. I did not hear you yawn.
Okay.
I can hear you just fine. Don't worry.
Okay. Okay. I messed up a bit with the settings on my microphone, and I thought you. Okay, okay.
No. I think my microphone is a bit too loud though.
Not for me.
I think I played with the gain a bit, so let me see if I can get it to not overload too much. Okay, I think this is better. Let me know if it's too low for you. Well, I guess you could just do it from Discord if it's too low, because I'm looking at the stream. Okay, so write functions to extract. Okay, write a function to increase the age, to increment, right? A user, right? So let me write this down. So increment age user, right? Okay, write a function that returns the user with the oldest user.
Okay.
So oldest, so it's you take two users and you return the one that's older, right? It's user to user to user. Okay. Okay. Let's see. So that's products and some functions for products. So, and yeah, we won't do anything specific for functions because most of the homework will be writing functions. So okay, so let's do sums now. So let's think. Okay, so then write a new type that has the following. I typed it wrong, right? Following properties. I guess I'm not sure. Construct. Let's just call them constructor. So I want it to be like type, which is the new. I don't want to call it user, but maybe. How should we call it? Person, I guess. Let's call it person. So a person could be either an employee, which has a I don't know, with what's a binary property for an employee? With a whatever, whether it's a new employee, right, or not, and we won't bother too much with what that means, right? And a manager with a whatever, it doesn't matter, don't worry about it. Right, so it's two okay, no, let's say two booleans. I want two booleans for manager. So with
Boolean for
two
super manager.
boolean properties that represent whether it is okay. Let's figure out something that's better. With two boolean properties, so let's see, one of them is whether I don't know, also an admin, and whether it has or whether they have their own office or whatever.
Oh, okay.
Okay, cool. So now questions for this, or what kind of exercises can we do for this? So write a function that write a function person to boolean, which returns true if the person is a manager. Okay. Then write. That's clear, right?
Yeah.
Okay, so write a function person to boolean, which returns true if the person is a, well, let's change this to being an employee. Person is a manager. Well, this is an okay, manager, and they are an admin and they have their own office, right? So all of them, right? Okay, and then I think this can be the last one, maybe. Well, no, this will be the last one here, and then I'll have a few extras after. So, and then the last one is calculate. Well, no, let's update something. Write a function makes the manager an admin what they were before and leaves the employee as before, right? So basically you have to check whether it's an employee, just return it as is. If it's a manager, then just change the admin property but leave everything else as it was before. Does that make sense?
Yeah.
Okay, and then 9, calculate the cardinal 4. So let's say data 3 equals 1, 2, 3, data 1 equals 1. Oh, well, this won't work properly. I'll do t. I'll add a t here, right? And by the way, I did not tell you. Well, let's do this, and I'll tell you next time. So I'll just add the type name as the like O for 1 and T for 3 and so on, right?
Yeah.
Oh, and then 2 has the same kind of thing. Okay, we don't need 2 actually because we have booleans for 2. Okay, so given this thing, so okay, let's say given this was the cardinality of 4. Data C, and I just call them C1, right? So C1 is C1, well, C1, 1, let's just call it for 3 and boolean, and then data C2. Well, let's just call them type 1 and constructor 1, and then type 2 and constructor 2.
Okay.
Okay, constructor 2, let's do a few more. So it's T1 and then 3. They're not necessarily harder and harder, right? I'm just writing a few random.
It's fine.
Okay, C3, C2. Wait, no, that's wrong. T2, T3. Okay, cool. Let's try not to make mistakes doing this. Okay, so T5, let's say it's either it's C5-1, which is going to be boolean, and C5-2, which is going to be T4. C6-1, which is going to be T1, C6-2, which is going to be T2, C6-3, which is going to be T4, 6-4, which is going to be T5. Data T7. Okay, now this is going to be later. I want to do something like T1, T2 here. We'll see. But then in meanwhile, let's say that we have data T7, and I'll rename this later, the bottom one. C7, which is 1 to 1. So do you know how to calculate this? Is this clear? So this is an exponential, right? A function from this. And then that's it, right? It's just a wrapper. So it's not a product, not anything else, right?
Yeah.
So it's just use the function and ignore everything else, right? You just use the idea for how to calculate functions. C8, and this is 3 to Boolean. C9. So let's say you have T2 to 3, 4. Okay, and then is the last one. Oops. C11, H is 1, or this. So well, let's do C11 2 and C11 1. And then C11 3 is going to be T3 and 3 2 3 4, and then also a T8 or whatever. And of course, like I'll tell it to you now just so you remember. Like once you've calculated T8 here, for example, you just use the result here, right? You don't calculate it again, of course, right? So that's why it's not as hard as it looks, because like you just do them incrementally. But like the reason I'm giving you a few more of this is one of them, they should mostly be simple algebra, adding, multiplying, and so on. But secondly, this is a very useful thing to have in mind, right? Okay, when I create a new type, how many different values can that new type have, right? Okay, cool. So I guess, this is the like quote unquote homework. Again, if you don't have time to do everything, that's totally fine. If you get stuck, you can always message me on Discord, and I'll be more than happy to explain off stream, and then we can go over it on stream if you want as well, or whatever. But like if you get totally stuck at one of the like earlier problems, then it's better to ask me early, like how do I do this, and then get you unstuck to be able to do the rest right on your own. Okay, well, I guess that's it then. Do you have any other questions right now, or?
I don't think I do. I feel like I understood like 80% of today.
That's awesome. So let me tell you that if you actually get some types, that this is the first thing that people get stuck on. When doing functional programming. So if you got this, then that's absolutely perfect, because like this is, if you understand some types, then you're well on your way to doing FP.
Okay. I don't feel like it was that hard, but like I'm still gonna have to work a bit too.
Oh yeah, so it's great that you got the basic idea, of course, but you'll need to work like to write, and it's important to do this sort of exercises just to get used to it, and then I hope we are able to relatively soon get to a place where you can write simple programs that like write your own programs, like things that you care about, like write a console program that will help you with whatever, like organizing whatever things you want to organize or whatever, right? Small little programs that, because it's important to start thinking about, okay, I understand these concepts, but how do I solve problems using these concepts, right?
Yeah, exactly.
But again, there's quite a few concepts that we need to go through, right? So we need a vocabulary first to be able to do that. So it will be a bit of time before we can do that. But wait, if we write pure script here, it will be easier to read. There we go. It will be highlighted in like here. Okay, cool. So, well, thank you again for being here. This is a lot of fun for me as well. So hope you've enjoyed it as well.
I'm actually looking forward for Thursdays now.
Cool. I'm happy to hear it. Okay, cool. So again, if you have any questions, any feedback, if you want to change anything, let me know, because this is important that it's well suited for you first and foremost, right?
I mean, it's really fun for me, but like I think people should say if I'm annoying in any way.
Come on, don't worry about it. I'm sure nobody thinks that. Yeah. Okay. Cool. So, like again, if you have if you're thinking it's going too slow or too fast, also please let me know, because we can probably adjust it a bit.
So far, it's been really nice for me.
Okay. Cool. Well, I guess I'll see you next week then. Thank you Thank you
Thank you so much.
Yep.
Goodbye, guys.
My pleasure.
Bye-bye.
Bye bye.